All right, so let's look at the last couple pages of the part 5 notes for chapter 7. The first part of that packet was solving exponential equations, equations that had x's in the exponent. Now we're solving logarithmic equations, so ones where the x's are actually in the logs and they're just kind of stuck inside there. And so we've got a couple different ways of doing these things. First of all, if you get an equation and it's just log base of something equals the same log base of something, well, then the somethings have to be the same. So in this, since they're both log base 5 on each side and there's nothing else in the equation, I know that the inside 4x minus 7 has to equal x plus 5. So 4x minus 7 has to equal x plus 5. Well, then let's see, what's that going to be? If I bring the x over, I get 3x. If I add 7, I get 12. So x ends up having to be 4. Now, the thing about log equations is the only thing that can ever go inside a log is a positive number. You can never even have 0 inside the log. So it turns out we gotta plug it back in and check. So really what you want to put here is check for extraneous solutions, because you don't always get solutions that work. Okay, so let's plug this into the calculator and see how this goes. So of course the calculator is not working. So let me restart it. Yeah, great. Okay, let me restart it one more time. There we go. All right, so I'm going to plug in 4. So check x equals 4. So if I plug in 4 into the first one, I've got log base 5, and then 4 times 4 minus 7, and that's 1.365. So log base 5 of 4 times 4 minus 7 equaled 1.365. Okay, so that one's good. And then if we check the other side, log base 5 of x plus 5, which is 4 plus 5. So alpha f2 log base 5 of 4 plus 5. That is also the same thing, 1.365. That's good. Okay. All right, so x equals 4 works. Let's look at the next one. They're both log base 10. They're both the common log. So 2x minus 7 equals 3x minus 9. If I bring the 2x over, I get x here. If I bring 9 over to the other side, I get 2. So there's my answer, and then let's check it. So if I type in log 2 times 2 minus 7, let's see what we get. Non-real answer. Okay, it turns out you get imaginary solutions if after you plug it in, the inside is a negative number, which this is, or 0. So in this case, log 2x minus 7 does not exist. So no solution here. So I actually would come back over here and cross this guy off and just say no solution. Okay. Let's take a look at the next one. Log base 4 of 5x minus 1 equals 3. There's only one log in this problem. There's not 2 like before. So the way that we can solve this when there's just one log equaling a constant is to switch the form using the rule that we always keep coming back to. Log base b of a equals c means the same thing as b to the c equals a. That's the key. All right, so if we rearrange this guy, it turns into b, which is 4, to the c, which is 3, equals a, which is 5x minus 1. Now 4 cubed is 64. If I add 1 to both sides, I get 65 equals 5x. And that means that x ends up being 13. So let's check it. Check x equals 13. So that's going to be log base 4 of 5 times 13 minus 1. Well, if we punch that into the calculator, let's click that. Alpha f2 log base 4 And then 5 times 13 minus 1. And it's 3, which is what we want. That's good, right? We wanted 3. So that's good. This answer works. Okay, in the next one, we've got negative log base 3 of 8x. If I subtract 7 from both sides, then this is going to be equals negative 5. And then I can, since they're both negative, really, I could just write log base 3 of 8x equals positive 5. And now at this point, I can rearrange using this formula right here, that change formula. So this turns into 3 to the 5th equals 8x. 3 to the 5th is 81 times 3, 243 equals 8x. So then that means x is going to be 243 over 8. And to check it, we'll use a calculator. Check x equals 243 over 8. So that's going to be 7 minus log base 3 of 8 times 243 over 8. And the 8's cancel, so it's really just log base 3 of 243. So let's see, it was 7 minus log base, what was it, 3, and then 243 right here. And that equals 2. Equals 2, so that's good because that's what we wanted. So our answer right here is a good one. Okay, E is a little bit trickier. So now we don't just have one log and a constant, or just 2 logs. We have 2 logs and a constant. So the way to do this is get the logs on one side, get the constant on the other, which we already have, and then combine the logs. Because remember, we have this rule too. If you have log base whatever of some number plus the same base log of another number, that's the same thing when you condense it as m times n in the one log. Okay, that we learned on the last handout. So in this one, we can convert the left side into log base 6 of 3x times x minus 4, all inside that one big log, equals 2. Okay, in fact, it might be better to do this so it's easier to see. Okay, well, that I can rearrange. I can rearrange that into 6 squared equals the inside 3x times x minus 4. So let's simplify that a little bit. That's 36 equals 3x squared minus 12x. And then if I bring the 36 over, I got 3x squared minus 12x minus 36. Now I could take out a 3 from everything. If I divide 3 on both sides, then I get x squared minus 4x minus 12. Well, you might figure you're going to have to factor. So I'm just going to rewrite the line right here. And if you can go straight to just factoring, that's fine. For those of you who can't, remember it's got to multiply to 1 times negative 12. And it's got to add to negative 4. And 2 numbers that do that are going to be, what? Negative 6 and positive 2. And that splits the middle term into negative 6x and positive 2x. So x squared minus 6x plus 2x minus 12. And then that'll turn into x, factor out an x from the first two, and we get x minus 6. Factor out a 2 from the second terms, get x minus 6. So 0 equals x plus 2, x minus 6. So we get 2 answers. X is negative 2 or x is 6. And then really, you got to check them both. So let me get rid of this stuff. So 2 answers. Let me shrink this so I have more room. Okay, so we'll check x equals negative 2. And if I plug that into log base 3, log base 6, 3 times negative 2. You can plug this into the whole thing if you want. As soon as you get to here, you're plugging in a negative number into a log. That's a problem. But let's say you didn't remember it. Your calculator will tell you it's a problem. Let's see, that's going to be, what is it? Negative 2 minus 4. And so the goal is that should equal 2, but it turns out it won't. Because if we plug this in, we've got alpha f2 log base 3, no, log base 6 of 3 times negative 2, and then plus alpha f2 log base 6 of negative 2 minus 4, and we get a non-real number again. So it does not exist, and therefore we get a problem with negative 2, so I'm going to come over here and cross off the negative 2. So then let's check x equals 6. If this one doesn't work, then we just have no solution. So if we check just 6, we've got log base 6 of 3 times 6 plus log base 6 of 6 minus 4, and the hope is that that equals 2. So let's try it. Log base 6 of 3 times 6 plus log base 6 of 6 minus 4. And it's 2. Yay, that's great. Whoopity-doo. And this one's good. All right. We got one last one. Let's try that, and then we'll call it. Oh, no. Then there's one more after it. All right. So anyway. Okay. So it's regular log of x plus 21 plus log of x equals a constant. So we can combine the two logs. So that's going to turn into the product of x plus 21 and x equals 2. Remember, no base written means base is 10, so this will turn into 10 squared equals x plus 21 times x. So that's going to be 100 equals x squared plus 21x. And then if I make that equal 0, I've got x squared plus 21x minus 100 equals 0. So if you can factor it, great. If not, use this x method. It's got to multiply to 1 times negative 100. It's got to add to 21. So let's see. That'll be positive 25 and negative 4. So that'll split the middle term. X squared plus 25x minus 4x minus 100. I wrote 0 twice there. So then the first two terms, we can take out an x. And the second two terms, I can take out a minus 4. And then I'm going to get 0 equals x minus 4 times x plus 25. And so then I get x equals 4, or x equals negative 25. And now we got to check both of these answers. So let me get rid of this so we have room. So check x equals 4. So that's going to be log, just regular log, 4 plus 21 plus log 4. So let's see what that equals. Log 4, whoops, plus 21, and then plus log 4. So that's 2. That's good. That was what we wanted. So that answer works. And if we check the other answer, which was negative 25, then I've got log of negative 25 plus 21 plus log negative 25. And we will get non-real answers. Does not exist. So I'm going to come over here and I'm going to cross off the negative 25. Okay, we got one last problem here. Let's do that. So we deposit $500. So the principal is $500. The annual interest is 8%, so 0.08. And interest is compounded monthly. So that means we're going to use the compound interest formula with the n in it because we can count that n is 12. So in this one, we've got a, so the general formula is a equals p 1 plus r over n to the nt. It's really a of t because it's dependent on time. And if we want to triple our value, then we want a to be 1500. So I'm going to put a 1500 right here, equals what we started with, 500, and then 1 plus 0.08 over 12 to the 12t, and let's solve for t. So if I divide both sides by 500, I get 3 equals 1 plus 0.08 over 12 to the 12t. And then we could simplify that parentheses, or since we're going to be doing this on the calculator anyway, let's just write this. Let's just do log base, and this is a terrible looking base, but the calculator is not going to care how ugly it is, of 3 equals 12t. Okay. In fact, we could even go one step further and just get t by itself. It's going to be this hideous log term with that ugly base, all divided by 12. So let's punch that into the calculator and see if it can do it. So we've got log base, and then the base is 1 plus 0.03 divided by 12. And then the number inside the log is just 3. And then we're going to divide the whole thing by 12 at the end. So t is 36.67 years, let's say. Let me make sure that works. Nope. Did I mess this up somehow? What did I do? I don't know. Let's check it. So if we do 500 and then 1. Oh, I know what it is. I did 0.03 instead of 0.08. This is an 8. Okay, let's try this. Let me recall this one. So I did it if it was 3%. I don't know why I wrote 3 instead of 8. There we go. 8. Boom. That looks much better. 13.778 years. There we go. Good. Didn't have to redo the whole thing. All right. Hope that helps a little bit, and I'll see you in class.